Hello students, today we will start our third chapter is transmission media. And then this is the transmission medium which is example for the some writing messages like transmission medium might be like a courier, or the N means the transport like airplane, bus, etc. Here the this chapter contains twisted pair cable, UTP versus STP, then categorize connectors, applications, coaxial cables, their standards, connectors and applications, then optical fiber cable, then unguided media like wireless, then it contains radio waves, microwaves, infrared, then light wave transmission, and types of cable and networking tools. Then first is here the transmission media is the medium can be defined as the physical path that can carry the information from the transmitter to a receivers. That means transmission media is a pathway that that carries the information from sender to receivers. And then we use the different types of cables or waves to transmit the data. We have already known this data is transmitted normally through the electrical or electromagnetic signals, and these transmission media are located below the physical layer, and computers uses the signal to represent this data, and signals are transmitted in the form of electromagnetic energy. In data communication, transmission media can be defined as the physical path between the transmitter and receiver in a data transmission system, and it may be usually like a free space, metallic cables or optical fiber cables, etc. And this information is usually a signal that is a result of the conversions of data from another form. Here one of the diagrams for transmission medium and physical layer first. Here one is the sender and another is the receiver between the physical layers, and one of the transmission medium like cable, air, etc. These transmission media are actually located below the physical layer, and these are directly controlled by the physical layers as shown in these figures. This is in 1869 a telephone was invented, and also it is needed as a metallic medium to carry the human voice. So communications was unreliable due to the poor quality of the wires, and wireless communication started in 1895. So today we have better metallic media like twisted pair and coaxial cables which we can use, and if it is invented, so use the optical fiber has increased the data rate incredibly, and free space like air, vacuums and water is used more efficiently. Here some computer and other telephoning devices also we can use like a signal to represent the data, and these signals are like transmission between from one device to another device in the form of like electromagnetic energy, and which is also propagated to the transmission media. This is the combination of electric and magnetic field. Combinations of like electric and magnetic field is called as the electromagnetic energy. Here in telecommunication transmission medium is classified into two types like guided media and unguided media. This is also known as the wired and wireless. And guided media classified into the three types. First is twisted pair cable, second is coaxial cable, and third is optical fiber cable. And unguided, that means wireless transmission media at having one of the type like free space, or it is also atmosphere. Then first type is guided media. It is also called as the wireless media. Guided media includes the twisted pair, then second is coaxial cable, and third is fiber optic cable. We have seen in the last diagram. The signal which traveling along any of these the media is directed and contained by the physical limit of the system. Then twisted pair and coaxial cables uses the copper, that means conductor, copper conductor uses and that accept the and transport the signal in the form of electric current. So and optical fiber is the cable that accept and transport the signal in the form of light. That means there are three types: twisted, coaxial and optical fiber. But twisted pair and coaxial cable uses the copper conductor, but optical fiber can accept and transport the signal in the form of light. So transmission capacity depends critically on the medium, their length, and whether the medium is point to point or multi-point. Then these three types included in guided media. Then we will see the three types one by one. Then first is twisted pair cable. In this diagram, this is the diagram for cables which is not drawn by the exam. This is just you have to clarify which is the twisted pair, which is the coaxial cable. For better understanding, we have included the diagrams. These diagrams also included in your book. Then first is twisted pair cable. Here the twisted pair consists of the two copper conductors and each with its own plastic insulation like twisted together. And this cables is least expensive and most widely used guided transmission media. This is the see, this is figure. Here this figure is the twisted pair cable and it having two insulator. Here it having one is insulator and another is conductor. This twisted pair consists of two conductors. These normally coppers made of from copper and each with its own plastic insulations. This pink color is the insulations. Here the color is pink. Suppose this is pink color and which is insulated with the plastic insulation, and here the under insulator or conductor is the made up from copper, and these are twisted together. One of the wire is twisted pair is used to transmit signal to the receiver and other wire is used as a ground reference. This uses the difference between two, and the wire pair act as a single communication link. Typically, a number of pairs is bundled together into the cables, and twisted make it probable with wires and equally affected by the external influences like noise, crosstalk, etc. Here they calculate the difference between two and receive the no unwanted signal. This is the benefits of the twisted pair cable. Then twisted pair cables can of the two types. One of the unshielded twisted pair cable and second is shielded twisted pair cable. Then here the some transmission characteristics of the twisted pair cables. It requires amplifiers every 5 to 6 kilometers for analog signal. Then it repeats every 2 to 3 kilometers of the digital signals, and it having higher frequency implies higher attenuations. Then advantages for the twisted pair cables: data rate of the several Mbps common. Then it spans distance of the several kilometers. It is good and low cost communications. But it having some disadvantages also in twisted pair cables. First is susceptible to interfaces and noise, and it is also attenuation with increase in the frequency. And then twisted pair cables having two types we have already seen. First is unshielded twisted pair cable, that means UTP, and shielded twisted pair, that means STP. Then first type is unshielded twisted pair, that means UTP cables. The most common twisted pair cables used in communications is referred to as unshielded twisted pair, that means UTP, as shown in this figure. First is UTP here. This is the twisted pair, unshielded twisted pair cable, that means UTP cables, and which is insulated by plastic cover. There it consists of two conductors, usually coppers, and which is its own color plastic insulators, which is identification is the reason behind the color plastic insulation. Then UTP cables consist of 2 to 4 pairs of the twisted cables. Here in this diagram it having two pairs. Then installation of the UTP is easy and flexible, and it is easy, expensive compared to the STP, but its bandwidth is low, and it also provides the less protection from the interference. For example, UTP are the Cat5, Cat6 cables. Here one of the example for one more RJ45 male, then RJ45 females. These are the extra included in the twisted pair cables. Then advantages of unshielded twisted pair: it is cheap. Then it is installation of the unshielded twisted pair is easy, and it can be used for high speed local area network. And then it having some disadvantages. These cables can only be used for shorter distance because of the attenuations. Then second type is twisted pair cables having second type, shielded twisted pair, that means STP cable. Here IBM has also produced the version of twisted pair cable for its use. So this is called as the shielded twisted pair, that means STP. This is the diagram for shielded twisted pair, that means this is actually shielded twisted pair. This is the STP cable, which is metal shield, and here insulations, outer insulation is a plastic cover. These STP cables has a metal foil or a braided mesh covering that encases a pair of the insulated conductor, and metal caching improves the quality of cable by preventing the penetrations of noise, interferences or crosstalk, but it has same attenuations as unshielded twisted pair. Here STP is faster than UTP and coaxial cables. Here metal casing improvement quality of cable by preventing penetrations of the noise, and it also bulkier and more expensive than coaxial and unshielded twisted pair. Here the some performance of the twisted pair cables depends on the attenuations, and we can compare the attenuation versus frequency and distance. Then twisted pair cables can pass a wide range of the frequencies. Then it having some characteristics. The cost of shielded twisted pair cable is not very high and not very low. Then installation of STP is easy. Then it has a higher capacity as compared to unshielded twisted pair cable. Then it also having higher attenuation. It's shielded, that provides the higher data transmission rate. Then disadvantages: it is more expensive as compared to UTP and coaxial cable. Then it has a higher attenuation rate. Then what is the difference between STP and UTP, shielded twisted pair and unshielded twisted pair? Here STP has a metal foil covering, then UTP does not have a metal foil covering. Then second is STP gives a better resistance to electromagnetic interference as compared to UTP. Then UTP does not provide a better resistance to electromagnetic interferences as compared to the STP. Then third difference is STP is a little expensive than UTP, and UTP is less expensive than the STP. Then grounding is possible. Here grounding is not possible in the UTP. Then positive of the crosstalk is less as it resists to AMI. Then possible of the crosstalk is more as to provide less resistant to AMI. Then disadvantages: travel in large and can be used in MAN network, metropolitan area network. And then in unshielded twisted pair, distance travels is less, and which is used to the local area network. Then second is coaxial cable. These coaxial cables or coax carries signals of higher frequency ranges than those in the twisted pair cables. It having the coaxial cable has the central core conductor of solid or standard wire, usually copper, enclosed in the insulation sheath, and which is turned and encased in outer conductor of the metal foil, write down of the combinations of the two, and the outer metallic wrapping serves both as a shield against noise and the second conductor which completes the circuit. And then outer conductor is also enclosed in an insulating sheath, and whole cables is protected by the plastic cover as shown in this figure. See, this is the coaxial cables insulated by the these two are the insulators. Here one of the inner conductor, then this is outer conductor, that means shield, and this is the plastic cover. It also having coaxial cables like this is the bridal shield, then this is the foil shield, then this is the center conductor, and last is outer jacket. This coaxial cable has a central core conductor of the solid or standard wires. That means there are the variety of the different types of the coaxial cable that are widespread use, and different types of the coaxial cables are needed for different purpose and different applications also. According to its necessary have specification and data to be able to determine the required coaxial type cables. That means these types are easily identified. There are the two basic systems that are used for defining the coaxial cables. One is originated in the United Kingdom, and its types number of all starts with UR, and the other systems is American with the types of number commencing with the letters RG. Then here the coaxial cable standards. RG stands for radio guides, and each RG numbers denote a set of physical significance. Then including the wire gauge of the inner conductor, that thickness and type of the inner insulator, and construction of the shield, and size, type of the outer casing. Here the table shows RG rating and used for the different applications. Here RG stands for radio guide, and it also having the one of the radio government ratings. That means there the RG category 59. Here impedance is 75 omega. Then it having the cable TV. Then RG 58 it having 50. Then it is used in thin Ethernet. Then RG 11 for 50, and it is also thick Ethernet. Then this is the coaxial cable connector. Then we need the coaxial connector to connect coaxial cable to different devices. The most used type of the connector, that is the Bionic concealment connector. Here the BNC cable, BNC stands for Bionic nail concealment, which is to connect the coaxial cable to devices. We need coaxial connectors. Then first is a BNC connector, which is used at the end of the cable to a device, for example TV set connection. Then second is BNC T connector, which is used to Ethernet network to branch out connection to computer or other devices. Then third is the BNC terminated, which is used at the end of the cable to prevent the reflection of the signals. Here this is the different conductor. First is BNC T, then this is the BNC connector, this is the cable, and last one is also BNC connector. This also contains the cables. These having the BNC terminators, which is generally used as a far end of the line, and resistance should be impedance of the coaxial line. Then coaxial lines, it having some applications: most versatile medium, television distribution, long distance telephone transmission. It can carry 10,000 voice call simultaneously. Capacity of the coaxial cable. Then short distance computer system links, then local area network. Then some advantages of the coaxial cables: easy to wire, easy to expand, then moderate level of the electromagnetic interfaces, then data can be transmitted at the high speed. It has the better shielded as compared to the twisted pair cable, and it also provides the higher bandwidth, but it having some disadvantages. Single cable failure can take down an entire network. Then cost of installation of coaxial cable is high due to its thickness and stiffness. Then cost of maintenance is also high. Then last type is fiber optic cable. A fiber optic cable is composed of the glass or plastic, and it transmits the signal in the form of the light. These optical fibers are a reflection to guide light through a channel, and in general terms, presence of the light is taken as a bit 1 and its absence as a bit 0. Here this is the physical descriptions of the optical fiber cable. This is the first. Here inside the core, then outer is the jacket, and this is called as the cladding. Then here this is the optical fiber cable. It having the light at less than critical angle is absorbed in a jacket, then angle of the incidence, and here the angle of reflection. The core and innermost section, here this is the core, consists of the single solid dielectric cylinder of diameter d1 and refractive index n1. The core is surrounded by the solid dielectric cladding of refractive index n2, that is less than n1. Then core material is used made up of ultra pure fused silica or glass, that cladding the either made up of glass or plastic. Then here this is the cladding. Cladding is surrounded by the jacket and it is made up of plastic. Then jacket is used to protect against moisture, crushing and other environmental hazards. Then three components are required: fiber medium, light source, photodiode, light detector. Here the nature of light. Light travels in straight line. If light goes from one substance to another, then the ray of light changes their directions. Then a ray of light changes the direction when goes from more dense to a less dense substance. Then here the three component. First is fiber medium. Current technology carries light pulses for tremendous distances, like for example 100 seconds of the kilometers with virtually no signal loss. Then second is a light source, typically a light emitting diode, that means LED or the laser diode. Running current through the material generate a pulse of light. And then a photodiode, light detector, which converts light pulse into the electrical signals. And a glass or plastic core is surrounded by a cladding of less dense glass or the plastic, and the difference in the density of the two materials must be such that a beam of light, that means this is moving through the core and which is reflected off cladding instead of being reflected into it. Then it having propagation modes. The current technology supports two modes of the propagation light along with the optical channels are multi-mode and single mode. This is the when signal goes from one point to another point, there are need of the propagation mode. Current there are two types. Here multi-mode, steps index and graded index, and then single mode. Here multi-mode propagations and single mode. First is single mode. The diameter of the core is fairly small relative to the cladding, and typically the cladding is the 10 times thicker than the core. And comparing the output pulse and the input pulse, note that there is a little attenuation and time disparitions. Then multimode, this is the fiber refractive index of the core which is uniform and undergoes abrupt changes the core cladding boundaries, and this diameter of the core is fairly large relative to the cladding. And note that the output pulse is significantly attenuated relative to the input pulse, and it also suffers significant time disparitions. These are the propagations mode diagrams. First is this is multi-mode source to destinations. Then second is multi-mode graded index, and last is single. This is the source and destinations. This is the difference. Here this is the propagation. Here single is straight. Multi-mode graded index these types, and multi-mode step index these types. This is the propagation modes included within the optical fiber. Here cable compositions of fiber optic cable. The composition of the typical fiber optic cable. The outer jacket is made up of material like PVC or Teflon to strengthen the cable inside the jacket, which is made up of the Kevlar strands. Kevlar is a strong material which is used in the fabrications of bulletproof vest, and there is another plastic coating below the Kevlar to cushion the fiber, and this fiber is the center of the cable and it consists of the cladding and core. This is the diagram for the optical fiber composition. This is the outer jackets, then this is the plastic buffer, this is the Kevlar for strength, this is cladding, or this is glass or plastic cores. Then optical fiber connector, it having 3 connectors, subscriber channels, that means SC, connect to the use for cable TV. It is used to push and pull locking system. Then straight tip ST which connected to the connecting cable to networking devices. And third one is MTRJ is a connector that is same as size as RJ45, and this is the SC connector. Then this is the RJ connector, and this is the ST connector. This subscriber subscriber channel, that means SC connectors. Then optical fiber advantages: greater capacity, data rates at 100 GPS, then smaller size and lightweight, lower attenuations, then electromagnetic isolation, more resistance to corrosive materials, then greater repeater spacing facility. Then it having some disadvantages: installing and maintenance need expertise, then only unidirectional light propagation, and much more expensive. Then areas of applications, here the telecommunications, then local area network, cable TV, CCTV cameras, medical education, SONET network, then subscriber loops. Here the difference between 3 cables: twisted pair cable, coaxial cable, and optical fiber cable. First is twisted pair cable. Transmission of the signal take place in the electrical form over the metallic conducting wires. Then here the electrical form over the inner conductor of the cables. Then in optical fiber, signal transmission take place in optical fibers over the glass fiber. Then in the twisted pair, it is a medium, noise immunity is low. Then here the noise immunity is higher, and optical fiber noise immunity, light rays, it is unaffected by the electrical noise. Then twisted pairs affected due to the extended magnetic field. Then coaxial cable is less affected and it is not affected by the optical fiber. Then in twisted pair, it is the cheapest medium. Here coaxial cable is moderate expensive and optical fiber is expensive. Then twisted pair is a low bandwidth, in coaxial is moderately, and optical fiber having very high bandwidth. Then attenuation is very high in twisted pair. Then attenuation is very low in coaxial cable, and optical fiber attenuation is very low, and installation is easy for a twisted pair cable. Then installation is fairly easy in the coaxial cable, and optical fiber installation is very difficult.